This is Miss Moriarty, and I'm here to discuss with us topic 7.3, which is all about thermal inversions. Now, we've seen this term before back when we watched our video on smog, right, when it spoke about photochemical smog as well as industrial smog. And really anytime we see smog or even fog or even dew on plants in the morning means that we most likely experienced a thermal inversion or temperature inversion at some point of the day. So what is a thermal inversion? It's going to be when we see a warm layer of air, usually at the kind of mid altitudes, cover a actually then colder layer of air that is dense and below and usually closer to Earth's surface. Now, what actually causes a temperature inversion? It's kind of like a multitude of factors. It could really be your topography. So areas that tend to be valley-like usually can have that cold air kind of sink below that warmer inversion layer. We tend to see thermal inversions happen more frequently at night or in the winter months. Or even when we see higher winds can all impact whether or not we might experience a thermal inversion. But a part of the reason why it's associated with air pollution is because when we experience a thermal inversion, it's almost like putting a cap or a lid, right, on the then atmosphere in that urban city or town. And so all the pollutants that could be producing throughout the day get capped and trapped closer to Earth's surface. So as a result, when we experience thermal inversions, we tend to see people experience greater cases of asthma flare-ups. We see more hospitalizations, worsened symptoms of COPD or emphysema. We could see decreased tourism revenue, especially if industrial smog or photochemical smog may be produced in that morning, right? It deters people away from wanting to visit a city. We could also see a decreased photosynthetic rate since now we are blocking sunlight, preventing plants from capturing sunlight. So how do urban heat islands play a role in all of this pollution? Well, remember, urban heat island effects usually impact more urban type cities that have very dark colored surfaces like asphalt, concrete, and darker colored buildings. Remember, that's because they have a low albedo, and so they tend to absorb lots of the energy or heat radiation coming from the sun. Now, as a result, we tend to see less evapotranspiration, water evaporating from surfaces, and transpiration from plants. This can wind up cooling off rural and suburban areas that wind up having more vegetation, so we don't really see this as often in a urban heat island area. So as a result, all of that heat kind of gets trapped in this very localized place. So this can then increase energy demand, energy cost. We could wind up seeing greater air pollution levels and heat, which then can translate to greater illnesses for those then individuals in that city. All right, at this point, here is our practice FRQ for 7.3. If you want to pause the video and take a moment to answer, please find a space in your note packet as well. All right, at this point, we should have answered our practice FRQ. So here it reads, geographic features, climatological factors can also play a role in the effects of air pollution. The diagram that we have here illustrates a city of millions of people and its surrounding geography. Human activities in those urban areas can release pollutants into the air that lead to things like ground level ozone and smog formation. The question asks us to describe how a thermal inversion would form in the city shown in the diagram. Here are the accepted answers here. One of which you could have said, right, the temperature gradient of the atmosphere is going to be altered, right, as a result of that cool ocean breeze, right, that brings that air closer to Earth's surface, causing then a warmer layer of air to then trap it. Versus describing, right, thermal inversions we know form when warm layer of air is going to trap that cooler layer of air closer to that Earth's surface. That cold air then ends up at the surface when things like mountains, which we could have seen right in our picture there, block that morning sunlight from warming any of the floor of the valley. That is then going to accumulate particulate pollution, ground level ozone, or smog, which has the potential to block any sunlight from reaching the surface. All right, everyone, that is it for our video on thermal inversion. Take a moment and just leave a question.